So I hope you finished 3A well. 3D is look at a lot of index numbers. We're not going to check out all of them. We're just going to talk about one that you actually see in the news and around everyday life. And so it's called the Consumer Price Index. So that might help you see why it fits in this index number section. So an index number is just a simple way to compare measurements from different times or different places. And we then shift it to kind of adjust it to that different time or different place so that we can better compare them, right? Because we want things as similar as possible to compare them. So if you'll see here, the index number is just the value divided by the reference value. That probably looks a whole lot like a percentage. And then we multiply it by 100. So we kind of sealed the deal that it's a lot like a percentage. But the reference value then must be really, really important. If I change the reference value, I change the index value. And I only want to compare values that have been used the same index value, the same reference value, I'm sorry. The Consumer Price Index, which is often abbreviated CPI, is based on the average prices for lots and lots of goods, services, houses. It's computed and reported monthly from the Bureau of Labor and Statistics. You can find it on their website. There's actually several stages of CPI. What we're going to use here, and the most common, is CPI-U. It's the Consumer Price Index for urban people, just because that fits the largest percentage across the country. It is slightly different for different CPIs because they look at different types of goods, services, and housing costs. We know housing costs is different all across the way and also different things. And so instead of just comparing like a 2-bedroom home, because that doesn't describe what the majority of people live in, they'll look at housing cost of renting, buying, all kinds of sizes, goods, how has milk changed, how has bread changed, how has oil changed for services. Medical is actually looped into a different CPI. But just like your everyday life items, how have they changed over the years? So we then report it as an annual CPI, which is just this average of the months. But I want you to look here. This is a CPI chart. It gives the years and the CPI. We currently use a CPI that uses the years 1982 to 1984 as a reference point. If you add these three numbers and divide by 100, what do you get? I want you to pause that and try it. Okay, if you average 96.5, 99.6, and 103.9, and then you should have got 100. So instead of using a specific year as a reference value, this kind of combination of those 3 years is used as the reference value, which is a little strange, but it actually is good. Then we're talking about an actual indexed number and not just referencing back to how things have changed from a certain year. Anyways, before that year, you notice the CPIs are smaller than 100. After that year, they continually increase. Now, there's a little hiccup every once in a while, but generally that's what we see as they get bigger and bigger. Now, if we wanted to talk about the rate of inflation, you see that down here? Oh, it's on the next page. If you want to talk about the rate of inflation that is based upon the Consumer Price Index, and what you do is find the relative change between 2 years. And so generally, the relative change, the rate of inflation is like 1 to 4%. Sometimes we see years where it's outside of that, it's an outlier, but that's what it generally is from year to year. Another thing, other than rate of inflation, we use Consumer Price Index to do is to compare prices from purchases from different years. So I might want to know what something today would have cost back in $1980, or I might want to know if I bought something in 1990 for a certain price, what would it be worth today? Assuming for these problems, and you'll see it sometimes in your questions, is that the only thing that's affected the price of stuff is inflation. Now, we know price is a very dynamic situation. It's reflective on, or economics wouldn't be a subject. But that's the best we can do, is to simplify it and focus on how would it change based on inflation. So you're going to use this formula, or your book simplifies this. I don't know if simplify is the right word. It go ahead and multiplies both sides by the price in year X. So you may see this equation if you read your e-text, or you just help me solve this from one of your problems. It's the same thing as that. If you are not a huge fan of solving using cross multiplication, then this one is one that you can kind of plug and chug. The problem is when people use this one, they don't always understand where the values have come from, and so I see people put values in weird spots. Is why I teach it with the ratio here, because the ratio here, you can see that the price and the CPI from one year are in top, the price and the CPI from the other year are in the bottom, because the differences in them will be some kind of multiplication, and they have to be the same, so they have to be equal. So you are going to put what you do not know here. This will be your unknown. Then you're going to put the price you're given here, and then you'll know what years these are, and you'll go up to your chart and pick out the CPIs from those years. So this will be a dollar that you don't know. This will be a dollar that you do know. This will be a CPI from the chart from the year that you don't know. This will be a CPI in the chart from the year that you do know. So let's try that out. Suppose you need to make $30,000 to maintain a particular standard of living in 2010. If you want that same standard of living, how much would you need in 2016? So we see these 2 years, 2010 and 2016. Now I'm going to go to the chart because I know I'm going to use CPI to figure out the differences in the two. So I should write this down. I need the CPI from 2010 and I need the CPI from 2016. So from 2010, the CPI I found is 218.1. From 2016, it is 240. All right, now we see that the later CPI, is it 216 or 218? 218, sorry. I see them at 2016. 218.1 and 2016 is 240. So we see how it's larger later. We expect similar things to happen. So this 30,000 is from the year 2010. And the year we don't have a dollar for is 2016. So I'm going to write that ratio from right here. I'm just going to write it with less words because some of you can be a little lazy. So I don't know the dollars for 2016. So there's the price in year X. I do know the dollars for 2010. So that's the price in year Y. So this is going to be the CPI for 2016 over the CPI for 2010. Okay, let's fill our numbers in then. This is what I don't know. X is our favorite variable, over 30,000 equals 240 over 218.1. To solve, you can use your cross multiplication steps and then divide if that's something you've done quite a bit with proportions. Or we can do the same thing to both sides, which asks me to, I shouldn't do that in that color. So I can do times 30,000 and times 30,000 on both sides, which will leave me with X equals, then I can multiply 240 divided by 118.1 times 30,000, and I'm going to get my answers in dollars, $33,012.38. It increased for a later year. If you were going backwards, you'd tend to see it decrease. How does it decrease? Well, if I had a older year on top and a newer year on bottom, instead of seeing this larger number up here, I would see the larger number down there. So I'd have a fraction less than 1. I'd multiply and I'd get a number less than what I started with. Isn't that interesting? All right, 2, find the inflation rate. This is the most skipped problem on your exam usually. I think it's because you haven't made the connection yet that inflation rate is a relative change. I'm not going to have that for you on your homework. That's something I need you to learn. But you will be given the relative change formula from 3A. So remember that is compared minus referenced over referenced. But I do need to remember that it's the compared and the reference is CPI. Now, I want you to do some older years that aren't in the chart, so I've provided them here. What is what here, though? So we have this number from 1931 and this number from 1932. How do I pick my reference value? If it's time frames, that's our favorite because the older one is the reference value and the newer one is the compared value. So this would be 13.7 minus 15, whoops, I messed up, 15.2, sorry, divided by 15.2. I'm going to go ahead and multiply it by 100. If I want to type all that craziness in my calculator, I might as well type all that craziness in my calculator. I would recommend the N over D button and the 13.7 minus 15.2 in the top of the fraction. Now press your down arrow from the circle keypad and put 15.2 in the bottom, arrow to the right so that you're no longer in your fraction, and multiply it by 100. And this actually gives me negative 9.87%, which is strange. Inflation is rarely negative. This is a pretty big deal and a pretty big outlier. But this is the correct answer, and you can see why it's negative. It's gone from 15.2 to 13.7, so it's decreased, and we don't see the CPI decrease. Remember back on our chart where it goes up and up and up and up? Yep, that's more normal. So what's going on here? Well, if you don't know, you might Google what's going on in the world in 1930. If you do know, this is a result of the war, of the economy from the war. So anyways, it's interesting to see the world of history and the world of math, for me anyways. All right, last example. The average price of a domestic air ticket increased from $260 in 1992 to $420 in 2016. Let's calculate the relative change in price. So remember, relative change is the formula we just used. It's compared minus referenced over referenced. And our referenced value will be this. Oh, no, it won't. Our compared value will be this number from 2016, and our referenced value will be this number from 1992, because reference values, if we have a time frame, are older values. So this is 428 minus 262 over 262. If I want it as a percent, which is how I report relative change, I am going to multiply by 100, and we get 63.4%. If you're still trying to figure out how I go from this to that, type it in your calculator, send me a picture of what it looks like in your calculator, the whole kit and caboodle, and let me check what you're doing if things are going awry. So it has changed 63.4% since 1992. And a lot of us are like, holy cow. But here's a bigger holy cow. Calculate the overall rate of inflation from 1992 to 2006. So we're going to again use compared minus referenced over referenced. We need the CPI. So look back on your CPI. We've learned before that the CPI for 2016 is 240. But we also need the CPI for what year? Look at your problem. 1992. So go back to your chart, look for the CPI from 1992. Don't just take my word for it. Go make sure you can find that it's 140.3. And then we are going to do the math. So if I subtract the two of those, I get that this is 99.7. The difference in the two, I am using this formula right here. And that the reference value is going to be the older value, so it's 140.3. And this gives me approximately, after I multiplied it by 171.1%. Ouch. That's inflation since 1992. So for some of you that seems like a long time ago, but it doesn't for me. I think I was in kindergarten. So it's a pretty big change, right? Then we're going to use those values to answer this question. The change in the domestic airline ticket prices, oh, this should be is, than the overall rate of inflation. So notice I've changed both of these to percentages so that I can compare them. So what I'm asking about is how does this number compare to this number? And so we're going to fill in our blank with less or more. So I want you to think about that. Which one would you put? The change is actually less than the overall rate of inflation. As expensive as airline tickets seem, they've actually decreased. Again, this goes back to economics. Because, well, one, we just have some airplane lines that don't charge that much, and two, because the demand has gone up, things, there's more tickets, more things to buy. So we are going to look at one other way you could answer that last question on C, plus just a good practice with our formula again. Let's say the price of the ticket increased solely due to inflation from that $262 back in 1992, then what would the ticket have been in 2016? So in 2016 dollars, what would that ticket price be? I guess in 1992 dollars, sorry. So remember, our formula is a ratio, so we have a price in the year we don't know. So the price the year that we don't know is 2016. We have the price in a year we do know, which is 1992. We have the CPI of the year in the top, needs to match. CPI of the year in the bottom needs to match. And so I'm thinking back to my formula because I practiced with it a bit. You may still need to look back at prices and CPIs. So let's fill that in. I don't know 2016. I do know 262. You need to be careful that you don't put 428 in there, right? Because I have seen that number, but that's not the adjusted due to inflation number. That's the actual value. CPI in 2016 is almost old hat by now. CPI in 1992, we looked it up a minute ago, it's 140.3. So to find this answer, X is going to be 240 divided by 140.3 times 262. And I don't know what that is. 240 divided by, I get $488.18. So we see that actual price was $428, and if it had just been inflation, it had been about $20 more. And so here we can see that the actual price was lower than what inflation would have dictated, and that again leads us to this answer of less. Okay, you need to practice with these. You will have a CPI chart, so have that handy, and you will have the formula that we've been using. Oops, this one. So keep those in mind as you work through these problems.